Hello, I'm Connie. Welcome to the mathematics world. As we know, in our normal life, there are a lot of places that we can use mathematics. When we have questions about some of the irritability of formula. In mathematics, integral assigns numbers to functions in a way that can describe displacement, area, volume, and other concepts that arise by other kinds of data. We can try to understand this in a different angle. Now, if I want to know the size of this basketball without using formula, how
First, and how to know the area for this circle, remember the integration that we learned. Define definite integral and the area between and the axis. So we can use the definite integral to calculate this area. Now let's draw a circle first. Let the center of circle at the point 0, 0, and its x-axis and its y-axis. And we all know the formula of the cycle is y squared plus x squared equal to 1. And we can write down the y squared as 1 minus x squared. So y equal to the root of 1 minus x squared. And we need to integral is 1. So we want to calculate the full area of this cycle is 1 minus 1 integral and the root of 1 minus x squared. So we can divide it into 4 parts, and this we can see the first quadrant is 1, 0, and the root of 1 minus x squared, and multiply 4 because we have the 4 quadrant, and we need to let x equal to cosine t. So we just put the x equal to cosine t into our integration. So it should be 4. Multiply 1 square and the integral O 2 pi and 1 square minus cosine t square and the d cosine t. And then we can write down it like the 4 multiply 1 square and the pi over 2. O pi over 2 and the sine t square dt. And then we can write down it as 2 pi over 2 0 and 1 minus cosine 2t, and it's equal to pi. So we can easily find the area of the.
Since we know the area for the circle, now we need to find the volume for the basketball. And what we do is we cut the ball into small pieces like this. First, we join a ball. It's 3 dimensional, okay? And we cut them into pieces. Then each piece of them become a small circle with height h and r is equal 1. Okay. And we calculate this small piece volume first. Since Natalie solved the area for us, so we can just use the answer is pi times h. Let's see, h0, and this piece is h0. And to calculate the whole volume, we just simply plus them together. Let's say 2hn, okay? We plus pi h1 plus pi h2 to pi hn. This is the volume for the whole ball. But what we need to solve this equation is we do the integration we learned with the same rule apply. Is we integration 0 to n. We lim h equals 0 and plus since 0 to n pi h, right? So we can write this equation into integration 0 to h pi r squared. The small r, then we can calculate for the integrate R for the original formula, which is V equal 2 pi 0 to R. Because it's 2 pi, so it's 0 to R. We just separated 2 parts. And root R squared minus X squared dx. Then we solve this integration. Is V equal 2 pi 0 to R squared minus X squared dx equal 2 pi R squared X minus 113 R cubed 0 to R. Then is 2 pi R cubed minus R. Then is 13 pi R cubed. Then the R is R equal 1, we know. So the answer is I. And we know we can calculate all the kind of, no matter what it is. If we know the function for the phase, then we can calculate the volume for the question. And sometimes we tried about the only rule, which doesn't we try to solve another one. We may discover a new way to solve the problems. If you try, everyone is